Okay, we all ready to go? Guten Morgen. It's a nice Friday. I'm glad you guys stayed around. I know how a lot of these events are on Friday. People start taking off early or having fun on Thursday night. So I really appreciate it. We're going to, hopefully you're in the right place, a 400 level session on building really large systems where we connect mobile devices to your back-end systems via Merge Replication primarily to talk to SQL Server and even beyond to talk to other back-end servers that you might have or your customers might have. So let's dive into this stuff. So again, I'm Rob Tiffany. I work on a little team out of Redmond. It's like a mobile business enablement team. And so I spend a lot of time on an airplane. I'm a professional airline passenger going around helping our largest global customers build really big systems. Sometimes people joke and say that the things I work on are only important for maybe 10 customers in the whole world. I guess I'll have to take it however I can get it. But yes, many of you and many customers I've worked with have wanted to mobilize their workforce, their enterprise, get that real-time enterprise going, devices out in the field, the Windows phones, whether it's consumer or ruggedized devices like you might have from Intermec or Symbol, Motorola, things like that, truck delivery drivers, all that kind of stuff. So they want to do that, and the best way to mobilize your workforce is basically, obviously the magic of wireless is the first key. And then data synchronization, things out on the device, SQL Server on the back end to push that data out there. So anyway, I go around and I help customers do that. I think more times than not, I find the customers already tried it themselves. I think they probably downloaded a white paper from MSDN that showed them how to set it up on their little XP netbook and got it working there, and they think they're ready to go for 20,000 devices. And so, this might sound strange. Has anybody seen Pulp Fiction? So I'm like Mr. Wolf, the cleaner. That's who I am. I'm the cleaner. So I come up and have to mop up the mess. Hopefully it's not as messy as the mess he had to clean up in Pulp Fiction. But sometimes I see a lot of customers who are making their best effort, but they don't know about all the tips and tricks of tuning and scalability and performance to support tens of thousands or maybe hundreds of thousands of devices and how to scale things out. And so over the years, I've gone through all that pain, but luckily I wrote it all down little by little, and I've published a couple books. I just had a new book, and David Good wanted me to come out and do a session based on the new book, but I'm going to kind of give you a talk. And basically, it's just a compilations of lessons I've learned over time and good guidance to show you how to build these things and exactly what to look for in tuning. So let's see and dive in here what we're going to talk about. So the big thing here is a lot of customers have data. They run their business based on data they've got in SQL Server, and they want to push that out to their mobile workers. And I will take a step back in a second here and say that maybe that data doesn't have to live in SQL Server for this to be valuable. It could be in DB2 on a mainframe. It could be in SAP. And I will talk a little bit, not a lot, but I'm going to talk a little bit about how what I'm going to show you fits into a much bigger picture. The next thing is I'm going to show you how to build multi-tier infrastructures to support to thousands or tens of thousands of users and show you exactly how to scale out and do that thing. And then I'll talk about just best practices. There's tuning, performance, scalability. And a lot of that I'll just do through some pictures at the end where we can so you can visualize it for yourself. I think my favorite tool, I don't know about you, I just love Visio. And that's pretty much where I live, and that's how I think, is in Visio. And so that's how I will best present it to you. And then, hopefully the takeaway is you'll walk out of here. If you don't walk out of here knowing about exactly how to do it, at least you'll have an idea that it's possible to do giant solutions with this. And then also, I have pointers. Obviously, I want to get in touch with most of you personally, if it's possible. If you need help down the road, either doing your own solutions or with customers, and I can work with you. But so first off here, I want to start off here before diving in. I'm going to just show you a picture, and this is kind of a bigger picture than just merge replication and sync. It kind of sync is part of this. But what this is there's this whole category, defined by Gartner, which we all know, and we all know that our own companies and our customers, they pay a lot of money to get reports from Gartner telling them how they should build their IT department and what they should do in different areas. And then, Gartner has their quadrants, and everybody wants to be in the magic quadrant with their solution. So one of these solutions, this scenario, it's called the Mobile Enterprise Application Platform. And there are a number of small companies that have products that fit into that category. And I guess what I just want to touch on briefly is to say that Microsoft also has a solution for this. And believe it or not, most of that solution, that core mobile middleware, really is SQL Server. And so, I should have brought my laser pointer here, but just kind of sitting back here with you just to look at these blocks, on the right-hand side, one of the keys is, you've got all these mobile platforms. You want to support multiple types of platforms, whether, it's Windows Mobile, it could be laptops, netbooks running Windows 7, whatever. We have a portable runtime. We have .NET for desktops and laptops and the Compact framework for devices. We have SQL C, which is our offline data store. So you should always be building your applications, whatever platform they're on. There always should be kind of looking down at the platform and the device and then letting the sync technology that goes between SQL CE and SQL Server over that wireless data network. Let that happen in the background when the network is available and when it's not, and then use the intelligence in the platform to help you with that, rather than building a solution where maybe like you might build on your corporate LAN where you're just calling web services as you need it. That doesn't work very well with mobile devices. Syncing, caching data is what does work well. And that's not just Windows Mobile. That's any solution. And so kind of what I'll talk about today is kind of the connection from out of the device in. And again, I want to be clear, it's not just Windows Mobile. The stuff I'm going to talk about works exactly the same on laptops and desktops. So everything is the same, it's portable. So you've got a much broader audience for this technology than you may think. And then how our sync technology works really well over unreliable networks, over slow things like GPRS or unreliable networks that are going up and down. We have intelligent retries, and we do little tiny blocks of data so it can do intelligent resumes and pick up where it left off and things like that, and compression. The next thing over here, though, is, obviously Visual Studio is your IDE that you're going to use to build your code. But great, with our sync technology, though, you write almost no code at all, which is great. There's lots of different sync technologies, and you write varying amounts of code to do it. Merge is the least amount. Then back here, the key thing is you kind of think of this block here in the middle as kind of mobile middleware. And for us, most of it is SQL Server. We're going to security all the way throughout. I guess the biggest important thing, though, is how from this mobile middleware, from getting to devices to the mobile middleware, then going over here to the left-hand side, these enterprise connectors. This is the other key element to a mobile enterprise application platform, is having connectors, adapters, that can reach out and talk to other back-end systems. Because I know that not every company runs SQL Server, or they may run it, but they don't run their whole business. Again, it might be running out of SAP, or it might be Oracle running on Solaris. And I just want you to know that our solution works with all that. We've got all these great adapters. And so whether the solution ends with SQL Server or SQL Server is just your middleware to move on to these other backends, we have a consistent solution with security all the way through to the end to talk to not only some of the guys you see listed here, SAP, Siebel, DB2, all these other kind of things. And you can imagine, HTTP can call web services out the back end. ODBC and OLADB can talk to anything. But there are many more adapters than just this that I don't even have listed. These are just the ones out of the box. All those WCF adapters for BizTalk will plug into SQL Server. And then for things you may not see, there's a whole third-party community building adapters to talk to other things. I can talk to MSMQ, but I can also talk to MQ series from IBM and WebSphere. So while I'm going to talk mostly about stuff on the right-hand side, keep in the back of your mind that this is part of a much greater solution that you can use for your customers to support just about anything. And I guess the reason you want to do that, and the reason you would want to approach your customer this way, or if it's your own employer at your own company, is mostly about cost savings and ROI. Mobile has been in its infancy now. We've been doing this for about a decade consistently now, for most of this first decade of the century here. And most people are building point solutions, just kind of one-off solutions here and there. The maturity level of mobile is growing as such that companies are now moving to a phase where they're not interested in doing point solutions over and over again. They want to standardize on a platform, and they want to reuse that platform over and over again. And so this is that kind of platform that you deploy one thing. It might be their SQL Server database that's syncing out to devices, and you do it. And the first time, there's a learning curve because you've never done it before. And then now they've got a different database, but maybe it's coming from Sybase and coming out through here. But you use the same solution. And so a lot of the same code, SSIS code works the same. You get it, the database works the same, the sync works the same. You'll build a different UI for your mobile app, but that's expected. You'll send different data down, but you're going to be doing it the same way. And then you'll do it again and again, and you'll keep reusing the same platform. And then your company or your customers, if you're a consultant, they start to see cost savings because they're not having to keep doing additional training. They already know how to use it. The developers, the learning curve goes away because they've done it once before. You may see over time that the need for doing pilots and different type of rollouts like that start to disappear because it's already working and you're just using the same thing over and over again. So there's a savings there, and then also a real hard cost savings around client access licenses. You're paying money for SQL Server and IIS and all these things for that first solution, but guess what? The second, the third, the fourth, the fifth solution, you're not paying for new CALs anymore because you're just using the same ones. If you're doing like CPU type licenses or things like that. So all of a sudden now, the more you use it, the more cost savings you have. And again, it's not just for our phones. It works on any of our CE devices or embedded devices, Windows 7, Vista, XP, little tiny netbooks, Slate tablets, ruggedized consumer, it doesn't matter. So you've got a broad solution, a lot of reuse, and so I think it's a good story to tell. I'm going to show you how to make it scale. It's one thing for me to say, this is this great solution. I'm going to show you how to make it rock and support the largest companies or governments on the planet. And once you add those two together, there's really nothing you can't do in the terms of mobilizing a workforce or governments or things like that, or military solutions, anything large. And of course, if you can do the large stuff, then the small stuff's real easy. So let's dive into this here. This is kind of a view of a typical scenario I see a lot of times that's great for our syncing technology. Lots of people, distribution centers, people placing orders, truck drivers sending products out to the field, customers at the end. I see this over and over again. You'll see it in retail, you see in you do stuff where work with food companies, work with delivery, package delivery, like a DHL or a FedEx or things like that, a Coca-Cola, a Pepsi, all those kind of things. That's a huge market. It's a huge market for us. And it's kind of, when we look at the enterprise specifically, we kind of divide the enterprise in half. There's this one analyst, her name's Maribel Lopez. She used to work for Forrester, and she's done a lot of analysis around that. And she talks about the carpeted enterprise and the tiled floor enterprise. And so currently, yes, Windows Mobile has a lot of competitors now today, as we all know, that we didn't used to have. But we still are number one in that kind of tiled floor enterprise. So all those truck drivers, package delivery, the factory floor, the refinery, the nuclear reactor, all those kind of things out in the field, we're the dominant force out there, and you'll see Windows Mobile running on all those kind of devices. And so, and that makes sense. People need a barcode scan, RFID, all those kind of things. So, our mobile application platform that we have and our synchronization is great for that. For pushing, new orders coming into the system, seamlessly syncing them out to distribution centers to know who's got to get what each day, and loading up the trucks each evening, and going out at 4 in the morning to start making deliveries to stores or packages, and then customers do that. So very, very common scenario. And the great thing is we have ways to, whether this is a small business or whether it needs to scale out across multiple continents, I can show you exactly how to do that. All right, so I'm going to kind of go through the different blocks, building blocks of what I would see. And some will be quick and easy, and some will be more in-depth than others. So securing the system is, security is important to everybody. It's great for me to talk a lot about features and technology, but you can't leave out security because somewhere along the way you're going to talk to the security guy at the company and they're going to grill you about that. So, it goes without saying, we use AD, your domain controllers, just for users and groups to manage everything, from whether it's coming from a Windows device or a Windows phone. At the application level, when they're syncing, you're passing through domain credentials potentially for security, and those credentials, when they go into your DMZ, whether it's going through ISA or some other reverse proxy, hitting IIS, hitting SQL Server, it's using that same security over and over again instead of lots of different types of security. And then, of course, personalizing different things by different users or different groups and different security groups. So it's easy enough just to use AD for all that, and it just works. Perimeter security, we talk about security, data at rest, data in transit. How does all that get secured? We've got a great story there. So as you can imagine, data in transit, obviously we've used SSL for a long time and that's built in for anything we do, whether it was Merge Replication or RDA, Remote Data Access, or Sync Framework, or just calling web services. It's easy enough to wrap that in SSL, and those can terminate in the DMZ if you like, or they can pass through into back-end service behind your back firewalls maybe in the company's data center. Additionally, you can use VPN tunnels. Again, ISA server, we have UAG coming out, we have threat management gateway coming out. They all have the same kind of things. They can, terminate VPN, L2TP, or different IPsec. We have mobile device manager, which is another solution we use to manage devices, but it also comes with this highly optimized VPN technology that's designed for mobile devices. Actually, it's really efficient. It's designed for bad networks, slow networks, and it kind of keeps a virtual IP address the whole time. So, as you're driving along and you leave coverage, when you get coverage again from another cell tower, there's lots of IP address changing as a mobile user roams around the internet. But this does a fast reconnect and keeps that same virtual IP no matter where you're going. So that's great stuff. So we got a good story around data in transit, data at rest. You know how data is secured in SQL Server and the encryption you can use if you want to, on the tables, things like that. Out on the devices, though, we've got that same encryption. The SQL CE database has a RSA 128 encryption on it. You can, for your applications you're building, these mobile solutions, you can always take advantage of crypto APIs if you need to encrypt certain bits of data all the way up to AES 256. Our platforms, our mobile devices can have policy sets down to encrypt the whole device to AES 128. If you're on a laptop, you can use BitLocker to encrypt the whole thing. So I think we have a great security story. That security story also passes through to the other end. When you saw the diagram about the application platform, out to the adapters, secure that connection out of the back of our mobile middleware out to other platforms. And so those SSIS packages, they can be encrypted and they can be digitally signed as well. So we've got a great story here around security. And so as you might imagine, I'm just going to switch over here. I'm only going to spend a second on it. I've just got a VPC here running. So again, and I kind of walk through this in the book. It's always good to start out, with your security story. But so in AD, you'll create sync users, and or it might just be any users you have in your company, and it's real simple to use. And there'll be some sync users you'll use too, that'll be used in SQL Server as far as running certain services. They may run under that kind of person because there'll be multi-server things going on. They need to talk to each other across the network. But just keep it simple. Have one or more sync groups that have availability to hit different things, and then just manage it that way. And then put all the company's users into those sync groups. And then when you put that group security at the SQL Server level, at the IIS level, it makes it really simple to manage all that stuff. So let's get to the heart of the system, the SQL Server Publisher. So what in the world is that? So that's your database that you care about. You've got this SQL Server database that you're using to run your business, and that's the data you want to be pushed out to the devices. And again, that could be the primary system, or it could be a gateway, a stopping point from something else, maybe Oracle on a mainframe. something like that. Maybe that's your main database, and through a data pump, through SSIS, you pump that down to a database on SQL Server, and that's kind of in between. But either way, that's what you're going to use to push out to your device, and we use terms that are like a magazine, like Publisher and articles and things like that. And so we have a way to make that database available. Articles are just basically tables that we want to push out to devices. Our merge replication technology, just make sure it only syncs the deltas in between, just what's changed. It's very intelligent about that. We have another sync technology called remote data access, RDA. It tracks changes on the device, but not on the server. And so it doesn't always do the deltas, but it's very lightweight. It's less intrusive on SQL Server. And so even though that may seem inefficient to you to not do deltas, it's so fast and so scalable that if you have scenarios where different users in the field aren't updating each other's data and don't need conflict resolution, it's definitely something you consider. And then, of course, we have the sync framework, too, which we keep working on. We've got a good story on the desktop. We're working on our story on the device bits there. The types of sync, upload, download, bidirectional, why do you care? Everybody thinks that syncing is always just bidirectional, but I think it depends on the scenario. So, for instance, if you always sync bidirectionally, you're always doing, and also when you think about the sync, just think this is just analogous to how Outlook works with Exchange. Outlook's sitting there on your laptop or on your device, and it's always kind of background keeping your mail in sync. And so we have the exact same solution, just SQL CE keeping your data in sync with SQL Server. Works the same way, but you don't always want to do bidirectional. For instance, most of the tables of data you're going to push out to your devices are reference data. They're lookup tables that don't change very often, and they certainly aren't changed by the user. So you can mark those as download only, and we do less change tracking on that, and that stuff works faster. And when I say upload only, what I mean by that is when you got your driver out in the field. I've got some customers who not only are using GPS plans or GPRS plans with their mobile operator, but they're not even unlimited. In many cases, they're not unlimited. They're capped to maybe only 5 meg a month or 2 meg a month. And it may seem to you, wow, how am I going to find a way to only use 2 meg a month? I know I'm going to blow through that. I'm in so much trouble. Well, the key to that is things like upload only. So you can imagine a great scenario in the morning over Wi-Fi at the distribution center. The devices might be cradled in Wi-Fi, and they do the big bidirectional sync. They get all the data they need for the day that tells the people where to go, what to bring, what to do. And then when they're out in the field and I'm delivering a package to someone and I'm capturing data on my device and I'm doing a signature capture, when it's time to sync that data, don't do a bidirectional sync, do an upload only sync. So it's only half a sync. So I'm just gonna send data that's up. I'm not going to check to see if there's anything new for me to pull down because I don't care. I'll do that full sync maybe later on. The key thing to create that real-time enterprise and keep your data usage low is just when you're in the field is just doing that upload stuff. And then keeping your data type small is huge. Other things you get with Merge, this whole column and row level tracking. Most sync technologies by default are kind of a row level tracking. If anything changes in a row that you're going, then potentially a conflict arises. If there's a row and I change the first name and Andy here changes the last name, then by default the system may say, oh, there's a conflict. You guys both changed the same row. But if you have column level tracking, I can change the first name, he can change the last name, and the system goes, we didn't conflict because we didn't change each other's column. Now, and so that can reduce the amount of data, too, going over the air. Now, there's no free lunch with any of this stuff because it requires additional change tracking as well on the back-end server to do that. But there is a lot of good flexibility. Filtering is one of the key, huge features of merge replication over other sync technologies. This is what allows you to take your giant database with 20 million rows and hundreds of tables and filter it down to something that could fit, on a little tiny device. And so you don't want all those rows to come down. So, and I'll take you through a wizard here in a second, but you limit the amount of tables, you can limit the number of columns, but then you can filter the number of rows as well. You can do it through static filters, which means everybody has their rows reduced, like through a where clause, basically. So everybody gets less data. There's parameterized filtering or dynamic filtering, where we kind of get into the notion of personalization, where each person out in the field with their device is a unique user, and when they sync, they send a filter value up, like I'm Rob or my last name's Tiffany, only give me the data that I care about. only give me the data that's in my region. And so that's how we filter down that data. And then the join filtering I'll show you in a second too. It's how you can, instead of having to write filter logic for every table, you can do it at a master table and then join lots of other tables to that same filtering. And the other cool feature we have in Merge is the notion of pre-generated database snapshots. So basically, the system can pre-create the image of the database, for whenever someone's going to do the sync for the first time, the most painful time because you have to pull down everything. We're not doing deltas yet. We have great technology in Merge Replication that allows you to, at night, let's say, to pre-create all these database snapshots. So they're sitting there waiting. And when a new user or someone who maybe their database is expired, their subscription's expired and they got to start over, these things are waiting for them so they sync very fast instead of doing the work of figuring out on the fly, oh, wow, what does this guy need? So great technology. This is what a typical, I say typical, maybe not for a small business, but for a lot of things I work with, for large systems, this is what a publisher might look like. So you're running Windows Server and SQL Server 2008, hopefully. Definitely 64-bit. Memory is your friend. It's part of the domain. So I look at the cores. If I jump to the bottom here, I've kind of made rules of thumb for myself over the years. And so I kind of think, one processor core and 2 gig of RAM for every 100 concurrent users. And keep in mind, it's not 100 users, it's 100 connected at the same time. Luckily, these servers are getting cheaper and cheaper, depending on where you are. And so a 32-core box, 64 gig of RAM, there's up to 3,200 concurrent users that could be hitting that box. I like to start out conservatively, though, and chop that number in half. And so maybe I would say with a customer, let's start out with 1,600 concurrent users. That could end up being a user population of over 100,000, but, just to get started and then work our way up. And then the other key elements here, and again, there's lots of tuning, and there's lots more, and I apologize, I don't want to be some guy who's plugging his book, but yes, I'm going to plug my book. All the answers are in the book. If I don't cover it here, there's very in-depth tuning things that I tell you about. But a lot of people who are DBAs already know about the importance of different disks and how things work on a database. So it's Database 101, different LUNs. And most importantly, if you can get unshared LUNs, where your data is not being shared with other people's data, where you have dedicated. RAID 10 is awesome. Use it where you can. Lots of people just do RAID 5 across, tons of drives. RAID 10, though, you get much better write performance, as many of you may know. So having OS and SQL on its own unshared ones, then the data, and those are all those kind of the system tables, and then your main publication table, on a dedicated RAID disk. Then the logs on their own. TempDB needs to be by itself on its own as well. TempDB, we beat up TempDB a lot. It gets a lot of work out, and so it's important for it to be out there. Especially, there's another functionality I sometimes recommend depending on the load, and especially if your SQL Server has to talk to another server on the back end to do kind of that adapter thing, ETL type stuff. There's a lot of work that goes on. There's a lot of optimizations that are done to the database to make sync work really well, but it also means that inserts and updates coming from other things have to jump through some extra hoops to keep that system in sync. And so sometimes I may say, turn your database into like what's called read committed snapshot, where it might use row versioning instead of normal locking on the database in order to reduce the amount of contention that's going on between different systems. And so when you do that, TempDB really gets a workout because TempDB is in charge of keeping of all that row versioning. And so having those dedicated LUNs for TempDB is important. Snapshot share, that'll probably live out with your distributor. And again, you can have a combined distributor and publisher. I haven't talked about distributor yet. I will in a second. But that's where all those database snapshots are out there. So lots of little folders with lots of files, BCP and other metadata files. That's where they live. They should be on their own. Use the fastest disks you can. If you can get 1,500 RPM, fiber channel is good. And then the queue depth, again, this is kind of obscure stuff if you're not into storage. But there's so many things to tune to get all the performance, and it's important to look at all of them. So that's kind of what a typical your middleware, your SQL Server would look like. So let's look at that for real here. I've just got my little, again, my VPC here. So in my book, I just created a simple database here, just a little distribution, kind of like that first picture you saw. And so as you can see here, it might be small, but I've got customers, distribution centers, I've got drivers, they're driving trucks, orders and order details, as you might imagine, the state of the order, the order's been placed or the order's been delivered, real simple, a bunch of products, and then the routes that you drive on. And so as you might imagine, drivers belong to routes, customers belong to routes, they both belong to distribution centers. Customers have orders have order details, that kind of thing. And then they all have an order state. So if I want to make this data available, right now it's just a database that I have. If I want to make it available to all my devices and laptops in the field, I need to publish it. So what I do here is I'm going to highlight local publications and right-click and say New Publication. And so unlike other technologies where you have to write a lot of code, this solution is a solution that every IT manager and director loves because it's a buy and configure solution. It's wizard-driven. Means that my team that's writing code to build my mobile app isn't also writing code to write sync code. So I run through the wizard. Contoso Bottling. Who would have thought that that company would be named Contoso? All right, so we're going to pick that one. Then we've got lots of different sync technologies. And again, think about maturity of sync technologies. And I'm not here to bash other Microsoft sync technologies because we're working on a lot of different things out there. But I am at heart a consultant, and I'm an advocate for my customers. And when I go out to a customer, my goal is I want to have the best solution, and I want to lower risk to the project because we all know that most software projects fail. And so I want my customer to get what they're paying for, and I want to lower the risk. And so I'm going to use a sync technology that's been around since we had, I think we called it SQL Server for NT back in, we launched it in 1995 after we went off of OS 2. This merge technology is the most mature sync technology there is. And so it's been around and it's proven. And so I feel comfortable with it. So we choose that. Then here we talk the different types of, SQL Server 2008 supports some new data types that 5 didn't, spatial and things like that. But I might just choose here to support SQL Server Compact 3.1 and higher just to keep my bases covered. And so we'll choose that. We'll go along. And then here it says, which tables do you want? So I can just click Tables at the top and check that checkbox, and it's going to get them all. I don't think I need to push sys diagrams down. But here's the first part where you get to start filtering your data, that giant database. So here's all the tables we just talked about. So I know that a lot of those are just lookup tables. They're reference tables. So I don't need to do change tracking and have SQL Server do extra work for me. I know customers is going to be download only. It's a reference table. Distribution centers is the same way. Drivers, the person on the device is not going to be changing drivers. Now order details and orders, those are transactionals and those are changing, so I'm going to leave those alone. Order state, that's just lookup. That's just 2 options. Products, that's lookup. And the same with routes. So right here, I just boosted my performance dramatically by marking a lot of these lookup tables as download only. Real simple. Not a lot to think about there. If I click on article properties, I can take a look at the highlighted article there. I don't worry so much about all this stuff here at the top of this, but things that you can look at here, there's this synchronization bidirectional, for orders it is going to be bidirectional, but it could be for lookup tables it would be download only, and that's different than the upload only thing that we talk about later that's actually controlled at the device. Overlapping partitions is another optimization you can do. Basically it says, are multiple people going to be sending the same filter or is just one? If you can say that just one's going to use it, we get further optimizations to improve performance. Tracking level, I kind of talked about tracking, row versus column level, things like that. So this is where that data is. Here's another thing that you get with Merge that you don't get with other technologies without maybe writing some code, or some of them just don't even have this. If you have scenarios where people in the field are going to be updating each other's data, stepping on each other's toes, then you might want conflict resolvers. And some technologies don't have them at all. Some you have to write a lot of code. this one, we have a default resolver that works great for everything. Then we have a bunch of built-in resolvers to decide who wins in the case of a conflict. And so we've got, over a dozen different built-in resolvers to decide who wins in a conflict, because that's important. And then even better, you can build your own conflict resolvers. You can build them in .NET if you want to. You can build them in stored procedures. And so you may have all kinds of scenarios. You don't always want the last one who adds the data to win, which is the normal default behavior on any website or any kind of thing you would think of. Last in always wins, because the last guy overwrites the guy before him's data. Because someone might do a sync and get on a plane, and he may be a vice president, and he might be making changes, but someone else might get the data on the ground, and he might make a change before that vice president's plane lands 3 hours later. But you want to make sure that VP wins because what he has to say maybe has more weight. We got resolvers that can help you do that, or you can write your own custom logic to do that. So it's really a powerful tool if you need that. Not every scenario needs it. Many scenarios don't need resolvers at all. A lot of places just need to download data, capture data, and sync it back, and they don't need anything. And for those solutions, our remote data access, like RDA, is a much better solution for that. Here it creates unique identifiers on the tables to do tracking. What I'm going to show you is something I've wrestled with for years is, should I be using identity columns for the primary keys and then adding GUIDs, or should I just make my primary keys a GUID and be done with it? And I used to complain about those both ways because I know a GUID is 16 bytes and doing a join, and that isn't quite as fast as it would be with an integer. But I've decided to punt on this one. And I'm going with GUIDs for your primary keys because my systems I'm building now are so giant, and they also use newer things that I'll tell you about later called republishing, where I have hierarchies of SQL Server to scale across the whole globe. And when the things get that big, I don't want to rely anymore. SQL Server has this great technology called identity ranges, and it'll allow you to do identity columns and gives different blocks of identity ranges to people. But when you start using multiple tiers of SQL servers for the biggest solutions, it gets a lot more complicated, and it's not worth it. You want to sleep at night. So just use GUIDs and know that everything's going to be unique. You'll never have a key collision or any problems there. So filter table rows. This is a really powerful feature of merge replication. And this is how we make sure that we not only reduce data for everybody if you want, but also we get just the right data to the right people. So I'm going to go through just real quick here. So let's see. We're going to start at the top of our hierarchy on the driver. So I'm going to say I want this dynamic filter. So I'm in the field, and so my last name is Tiffany, and your last name might be Smith. But anyway, I'm going to put in a filter, and all these filters are a simple where clause. And basically it just says, for this one, where those columns, where last name is equal to, and I'm not going to put, if a static filter might be something where, I'm from this country, I'm from Deutschland, and so I might say where country equals Deutschland, and it would apply to everyone. But if I want a dynamic one like this, I'm going to use this keyword. It's a function in SQL Server, and it's called hostname. And I can't spell. And of course, in virtual PC, it's just every little keystroke kind of, you don't know if it really happened. So anyway, you'll do where last name is equal to host name. What that means is when the device syncs, the laptop syncs, it's going to send a dynamic filter. In this case, I'm going to send my last name, Tiffany. And then it's only going to give me things I care about based on that. And then down here, there's an optimization. A row from this table goes to multiple subscriptions or only one subscription. What that means, the first choice means that the possibility exists that there's going to be multiple people sending Tiffany's or last name. If that's the case, it won't be as optimized as it could be. But if I can guarantee that there's only one driver out there and their last name is Tiffany, I do this, and you'll see dramatic performance improvements. So that's just a simple example of a filter. But then to take it further, we talked about drivers belonging to routes and all that kind of stuff. So we can add join filters, and this is a great technology. And again, this is a no-code technology that makes it easy for you to do this. So I go, okay, I've got drivers, and drivers belong to routes. And so I can go here and I can click the combo box. And so I find that I've got a route ID in the driver's table, and guess what? Obviously, I have a route ID in the routes table. And if I say this is a unique key and it's a one-to-many or one-to-one, I get further optimizations here. And again, I'm all about optimization because it's when you're supporting a lot of users. So you got routes here. We can extend also drivers. Drivers belong to distribution centers. Actually, I meant routes belong to distribution centers. I'm sorry. Come on. Anyway, what it does, you can create yourself a hierarchy that goes down. You don't want to go too deep because, SQL Server has to do that work every time you do a sync to see what comes back. But this kind of gives you an idea of how you can filter it down so that you only get the stuff you want. I only want stuff about my driver, my routes, the distribution center that I get my stuff for every morning to go out to my customer. I just want my customers, and my customers just want their orders and their order details. Yes, sir. I'm sorry, is it what? It'll sync through the tables, through the related tables, through the foreign keys. That's how it'll do it. Which is also an important thing to think about, is primary and foreign keys and indexes. Just like anything else with database, it applies here. Very important for performance. So anyway, I could build a much deeper hierarchy, but for sake of time, let's just move along. So now we'll create a snapshot immediately. A snapshot is just kind of that little quickie image of the database. The schedule, again, it's set to every 14 days. That's not good for me. I want it to do it every day. So maybe do it in the middle of the night, every night. So it's going to create a new general schema snapshot every night for me. I've just noticed in my own personal experience that works a whole lot better for me for not running into strange problems. Security settings. This might be a scenario where I talked about how you might create a domain user to run this process under instead of just doing it as a SQL Server agent. So I created, in this little network I created on my laptop, I've got a domain called sync domain. And then I created a sync user. And so I'm going to run this as sync user. So I did that. We're almost done. Again, it'll create the publication right there. If you check this checkbox, the script for all the crazy stuff you may have done in that wizard, it'll save the script so you can rebuild it later and save that off. Good for ease of use. It's also good for disaster recovery if you need to, when you're starting from scratch. And then I'll call it a name, so I'll just say it's Contoso Pub. And then click Finish, and it'll start building that publication, and there it is. So now it's created for me. And so now let's go take a look at what's been created, because I might have further optimizations here to look at. So I'll just go to Properties. So the first thing I want to look on this first screen here, this is a critical one. Subscription expiration. Basically it says interval by default 14 days. So what that really means is I sync my device or my laptop the first time, I pull all this data down, and then the timer starts for me. And so SQL Server has got all these hidden tables that are storing all the data that I care about, inserts, updates, and deletes for different tables, and it gets even more complicated when you have the different partitions, the filtering. And so it has to keep track of a lot of data, and that's the biggest kind of linchpin, the pain there is in the system are all those tables tracking data for you. And it gets bigger and bigger, and the bigger it gets, the slower things can get. And so having this set to 14 days, it would seem like the worst case scenario to me. It's kind of our normal default. I have some people who want to check this little radio button that says it stays forever, and that's a recipe for disaster. So what I want you to think about is I want you to keep that day, the expiration, as low as possible. So what that means, I try to think if I've got route drivers out in the field and they go do their thing every day, I don't want to necessarily say that I'm going to set it to 1 day because I know they sync every day because they don't work on the weekends. And then maybe sometimes there's a long 3-day weekend. So maybe it's 4 days, maybe it's 3 days. Then then when a subscription expires, all that metadata is cleaned up, and they have to do a new snapshot. So they start over. And I know lots of people don't want that to happen because they think, oh, that's so painful. Don't make them start over. Just keep tracking. Well, guess what? There's nothing more painful than this giant growing metadata on the server. It's much worse than the snapshots. And so if you use some of the tuning techniques I talked about, and it's in the book, and then there's a way to rebuild these snapshots every night, and not just the generic snapshot that you saw me set, but I'll show you in a second if it should show up here, where I can pre-build snapshots for every single filter value for every person, every unique thing, and pre-build them. And so that if their subscription expires, let's say we did the 4 days, but I went on holiday for a week or 2 weeks, and then I come back and I try to sync, and my subscription's expired, there's that snapshot waiting for me that's going to come down very fast because it's already pre-built, and if you're doing it every night, the snapshot should be the freshest data that looks as much like the real database as possible, rather than an old one that's created every 14 days, and then I pull down the snapshot, then I still have to do logic to catch up to where the data's changed between now and the 14 days before. Also, one other thing. Some people are afraid that if their snapshot expires, what if that person's been capturing critical data in the field, and how do they get it back? Because when you start over, it basically says, I'm deleting your local database and giving you something new. Don't worry about it. There's this great thing. One of the methods you call when you have expire on the client side is called reinitialize. And then there's a parameter you can pass. If you pass true to reinitialize, the way it works is when you call that method, then you call the synchronize method on your laptop. And when you do the sync, what it does first is it uploads all that data you captured all that time first, then blows away your database and sends you the new stuff. So you're never going to have that scenario where you're going to lose data, which is critical. So let's look at here. Some of this stuff will just be a reflection of what we did in the wizard. So the articles is what you already chose. Filter rows, you kind of see the view of the hierarchy we created. And again, for this scenario in the book, I have a different, a little more to it. But it also lets you know that I can come in. If I didn't do it the way I wanted to when I created the wizard, I can always come back and make changes here, or I can add things. But again, sometimes, I don't know if this is a worldwide expression or not, but I know in America we talk about giving you all the rope you need to hang yourself. That's kind of what we have in our technology here. And I've seen lots of customers hang themselves, and I see them hang themselves right here. Filtering is great when used kind of like a lot of things in life in moderation. Just do the minimum that you need to make it work. But I see lots of customers try to put lots of complex business logic and doing lots of extra filtering and in clauses and all kinds of things. And I've seen where I've looked at someone's screen and there's filters going all the way from the top to bottom, and there's a scroll bar, and it's just going down to the floor here. And I see hierarchies going 6, 7, 8 levels deep in that direction. There's a cost to be paid for all that. Every time a sync happens, SQL Server has to grind through all that to determine that. So when customers show me this giant mother of all filter screen, and they're going, I don't know why our system is so slow. It's because they hung themselves. So anyway, moderation is key. Snapshots, it goes into a share folder I kind of talked about earlier. You want that on its unshared LUN. And that can get big depending on the number of unique users. Let's see, we don't come out here. Subscription options, this is a key thing. Since we haven't done anything yet, some of this is grayed out. But the parts I want you to think about most, once it starts doing its thing, this parameterized filters is true. And then down here, once this would become ungrayed out, you want to set pre-computed partitions to true. And so that's a further optimization SQL Server does to know in advance what you're going to ask for when you sync based on your filter. So instead of, just like how we're going to do pre-built snapshots for people who are starting out, also every time someone syncs, I don't want SQL Server to go, okay, your filter, your last name Tiffany, I need to think about, I'm going to do all these queries and get you the stuff right now and then give it to you. If you have pre-computed partitions turned on, it's already thought about that in advance, and it's already pre-built the metadata, and it's waiting for you so that you get an even faster sync than you would otherwise. So it thought about it in advance instead of thinking about it on the fly. A huge, huge difference there. The other critical thing here is limiting concurrent partitions or processes. These merge agents that run, and they're doing their work, and there's admittedly lots of locking and blocking involved when you have lots of merge agents all trying to sync multiple people at the same time because they're all looking at the same tables and they're updating metadata tables. So unlimited is a recipe for disaster as well. So you want to limit the concurrent processes. And then my rule of thumb kind of goes back to how I told you about the 1 processor core and 2 gig of RAM for 100 users. So you imagine I got my 32 core server. So being conservative, let's start out with 16 and then start doing testing, stress testing. And I've built a stress test tool I can talk about later. You know, I can give you information on how you can build your own tool to stress test and simulate thousands of users before you actually deploy them. But start at half the number of cores on your server as that, and then work upward. If you can do it and if things are working fine, then maybe try 18, then 20, and see how it works. So that's critical. Security, publication access list. In this case, we'll click Add because we map our domain objects to SQL Server objects, and so sync group. Again, just like in anything, it's easier to manage groups than individual users. So we're going to add that group. We already know what our agent security is based on that sync user. And then data partitions. This is that one thing I talked about. It's grayed out still because the whole system hasn't initialized yet. But this is where, well, I can check this checkbox and it'll automatically create a snapshot on the fly for people using BCP, which is faster than the other way. But also, if this wasn't grayed out, I could click Add, and I could, either by hand or I can automate this process, have nightly SQL jobs that are going to create individual filtered snapshots for every single filtered possibility out there. And it could be 100,000. And so depending on the window of time you have, you might be able to do it every night. You might have to do it on the weekends. But again, all that optimization and pre-creation is critical. So now let's get out of that, and let's move along here. Distributor. As I said, distributors does some different functions. It's not quite as important in this kind of technology as it is from our transactional sync. But it's kind of managing all the people out there, all the agents and metadata and history of what's going on. The snapshot share usually resides on the distributor if you have it broken out into a separate server. But lots of people just keep it on the same server. As long as you're doing a great job with your SAN and unshared LUNs, you should be in good shape sharing that, and have plenty of processor cores. So what I'm going to there's the merge agents and snapshot agents. So what I'm going to take a look at them really quickly here before we move along, because I can't believe it's already 11:40. I don't know where the time goes. So here's another secret tuning tool here. Right-click on replication, click distributor properties, and then we're going to click on the profile defaults. All I'm going to care about right now, I'm not even going to worry about the snapshot. Let's just look at the merge agents. This is where all the hard work's happening. That's those concurrent processes. So right now there's this default agent profile. And basically what it says is merge agents. So think of these little executables launching in memory on SQL Server every time someone has to sync. There's these notion of batching. When you do a sync, I don't do all the work all in one time. I do round trips, and I do batches of data. And one of the great things about replication and the technology we built with SQL C and on IIS with these little blocks is we built this from the very beginning with the original compact IPAC in mind, with almost no available memory. I always find, and I think you do too, if you build software with the worst case scenario in mind, then everything else is going to take care of itself and work great. as opposed to maybe building a solution with a desktop in mind on a fast LAN with 4 gig of RAM and quad core, and then hoping it works on a device. So we built it in the worst case first. So we built it with this notion of batching and how many generations. Generations are just changes that are all grouped together, or metadata tracked. And so by default, you can see here, 50 generations per batch, and then these read and write changes. All these little parameters you got. Max BCP threads. It's going to use 2 to do that. Upload, polling interval, deadlock retries, all this kind of stuff. So what I want you to do, though, is, at least I found this to be true, is this other choice is called high volume server to server profile. And this is when you're doing SQL Server to SQL Server. Well, guess what? For the most part, it works great with devices too, with SQL CE. If I have you choose that one instead, then all of a sudden you noticed that now instead of 50 generations per batch, I'm doing 500. And now I'm doing things like parallel upload and download has been enabled. Max BCP threads has now gone to 4. A lot of different changes have happened. You can also create your own custom profile, do your own testing. And again, remember, there's no free lunch with anything. If you're having things that are using more threads, remember that you've got to have the cores and availability to do that. But by making the optimizations here, I've been at customers where they were complaining it was taking 30 minutes to do a sync for some giant amount of data. And I remember doing lots of tuning here and creating custom profiles along with a lot of work. And I remember feeling great that I went from 30 minutes down to like 1.5 minutes, for a giant 400 meg database. Yes.
This high volume profile, would that be suitable if you're using low-bound applications?
No, it wouldn't. It wouldn't. If you got GPRS, you might want to stick with the slow one. But I guess what I would always say is I'm often surprised by what I find. I know we all want this to be a science, but unfortunately there's a little bit of art to it. And so I guess the takeaway is I have a lot of knobs for you to turn here. Turn them and do your own testing, because I noticed everybody's scenario is different. And so I don't think one size fits all, ever. But you're right about the low bandwidth. If you're trying to force through more data, then it's going to happen, that's probably not going to work out so well. So we talked about tuning distributed. Now, IIS. IIS is kind of our gateway. We're instead of using, the merge replication and transactional replication technology we've had in the core engine forever is actually a super efficient, high-speed binary server-to-server thing. But for devices out on the internet roaming on wireless data networks, from Vodafone or whoever, we needed to make that work over HTTP and HTTPS. And so we added IIS, and we added these server agents that run on IIS that basically it talks to SQL Server over that high-speed binary protocol to reconcile changes, but it also translates into our own kind of highly compressed format that goes over HTTP. Don't confuse that with some big bloated fat wire protocol like SOAP or datasets. It's very efficient, it's very fast, and it's all compressed. And so that's what IIS is used for. If you're running on IIS 7 now, or 7.5, if you're running on Windows Server 2008, you will have to add these little compatibility components for IIS 6 until we make some changes. But keep in mind, this server agent, there's a 32 and a 64-bit version for that now, so that's great stuff. But it does all the work, and I talked about these small blocks. It reads and writes in. Think about this as a message queue. It's an edge message queue kind of server is what's happening. It's this replication session control blocks, which is part of the magic of how well it works, how well it worked on that iPack that only had a few meg of memory available, and how great it's going to run on your netbook or on your full-powered laptop. These session blocks mean that it never you'll see these in and out files being written to the hard drive on your IIS server. And those are going over the air in little tiny blocks. So one of the things it means is if I'm driving along and I'm doing a sync while I'm driving my truck and everything's going fine, then all of a sudden, oh no, I drove outside of coverage and I don't have wireless coverage anymore. It doesn't mean it just fails and it starts over. I have all these tuning parameters. One of them is called connection retry timeout that I can set to a minute or 2 minutes, and it basically says if I'm syncing and I lose coverage, if I drive back into coverage within that 2 minutes, I will pick up the sync right where I left off. because it's sending tiny blocks. And so it's going to just intelligently resume. It's not going to have to start over again and make you wait. So that's great stuff. But the other key, those same tiny blocks mean it will never overwhelm the memory working set on your client, your device. So if you are running on a really low-end phone that has very little memory left, that's the great thing, is these blocks are never going to go try to send some giant data set or huge structure into the memory of your device that's bigger than the memory you have. So that's key. The agent also, so it's a nice happy DLL. It does that work. It also queues up people, so multiple, you could have hundreds of people trying to sync at the same time. It'll put them in a queue waiting in line while the free worker thread is actually doing the sync. And you can change that by the registry. And this is what one might look like. And the great news about this is it doesn't have to be the super powered server. This one, I always said, just get the cheapest pizza box 1U with dual core and 2 gig of RAM, because I found that less is more everywhere. And so having more of these little low-end pizza boxes and load balancing them works better, and limiting the number of users that can sync per box works much better than trying to turn up the number of users that can sync on a bigger, more powerful box. Now, what I just found personally, and you may not find this, the last customer I was building, an insurance company in Atlanta, and we built this giant, and I'll show you a system, and wow, I'm almost out of time. I'll show you this giant system that spans 2 data centers and geo load balancing over, private circuits and things like that. But the key thing here, when I tried to buy from them, I found out that IBM no longer made just cheap dual core, it seems like the new low end is quad core now on servers, which is great. But the key thing here is this max thread pool. Per pool, you see it is equal to 2. And actually, let me just jump into the registry tool here and show it to you. So you go to the registry editor on IIS, and you'll hear under the SQL Server Compact, edition 3.5 and transport, you're going to see all these items here. So let me pull this back so we can see the values. So max pending request. Basically, that's how many people am I going to allow to queue up waiting in line to sync. So the default's 500. What I would prefer you to do, again, with the thinking of less is more in my experience, is use a lower end server and limit that to 200. 200 users, 2 cores, 2 gig of RAM, matching halfway to your server that goes out with its cores and its equivalent RAM. It's easy, and I talk about the calculations to do that in my book. So it's real simple for you to figure it out. And so when I limit this, it means, because I found that overwhelming the system and letting everybody in does nothing but destroy performance and scalability. But if I let fewer people in and fewer people to do things, magically more work gets done and more people get their job done. And it seems counterintuitive, but that's just how it works. The most critical part, though, is this max threads per pool. So it creates 3 thread pools. One for writing those in files and the out files, the blocks going in and out, and then one doing the reconciler, talking to SQL Server. By default, it says 20 per pool, so that's 60 threads potentially out there on your IS. Well, we all know that there's no free lunch, and what are all those threads going to be doing, Anyway, it might seem surprising to you, but I have found in my own testing, in my own giant rack of servers, that 2 is the magic number. 2 threads actually syncing at any given time, 2 cores, 2 gig of RAM. It doesn't sound like very many, but if I lighten the load, and so this is kind of a gateway into SQL Server, and it also matches up with, remember how I had you limit the concurrent users on SQL Server, so maybe I set it to 16. So that, guess what? That's 8 IIS servers load balanced in front of one box with 16, and it all matches together, and it works like a champ. Fewer people get in, SQL Server does more work faster, gets you in, gets you out, and lets the next guy come in, rather than trying to overwhelm it and let everybody in. Because what happens, customers are always shocked, or they go, wow, the CPU is really low on SQL Server. I don't think we're doing much work, but nothing's really happening. I think SQL Server gets shocked and paralyzed when you try to let hundreds of people all do it at the same time. Nothing happens. But as soon as you reduce it, the CPUs go up, more work gets done, and people get in and out faster. Of course, another critical deal is back to Database 101. Can't tell you enough how important indexes are. Because You might get one person in to sync, and they're syncing really fast, but you look at the CPU meter on SQL on Windows Server there, and you see it's all at 100%, but you're doing great work. But it should also tell you that when you have two people in, if you're already at 100%, your performance and scalability is going to go down. And so, those indexes on the keys, the primary foreign keys on all the where clauses that are all impacted in those server filters, that is so huge. And, or we have the tools in SQL Server to find missing indexes for you. And it's just magic how all of a sudden SQL Server found a missing index, you enabled it, and all of a sudden the CPU goes all the way down because it's not doing table scans to get its job done. So it's critical. Subscriber is the last part. It's real simple. There's an object called the SQL replication object, and you're just going to set a bunch of properties and call synchronize. And I'll show you that code here in 2 seconds. It's just real simple. So it's almost, I always like to say that there's no coding involved. There's a little bit, but almost nothing. One other thing I want to put on here, because it's also a subscriber, and there's a whole other session that I've done on this before. It's called a Republish Er. And this is a way to build kind of a pyramid hierarchy of other SQL servers that subscribe to the main publisher, and then they republish. They get a database, and then they run the publication wizard against their subscription to republish it down to another tier of SQL servers. If you find yourself, because any server, whether it's Oracle or SQL or anything, it's going to have a limit, a saturation point where it can only handle so many users. It doesn't matter who it is. When you find what that is, I want you to know that that's not the end. You're like, wow, I gave it all the CPUs and memory I can, and this is as far as I can go. It's not as far as you can go. You can use republishing to build a pyramid hierarchy that could either just all have the same, unfiltered data going, and so then this group of users hits this one and this one here, and it doesn't overwhelm them. Or you can also use filtering there, and I could have a server that's sending data down to a republisher for the UK and a republisher for China and things like that. So, and great story there. So let's, I'm going to quickly look at the subscriber. Basically, what I do is I, create a little config, have my config file on the device here, and so I put these are all the different parameters you can use for the local database, the publication, the name of that server, the security mode. Am I going to use integrated security or not? The usernames, passwords that each person's passing in. What you also see here, and you can tell I've been just doing a lot of crazy stuff, is I have failover publishers, failover machines that can go to different data centers. Things like internet URL, you just call in a URL to that ISAPI DLL. The host name, in this case, I kind of just for fun, employee 25, but that might be the driver's last name. Anyway, the distributor, if it's on the same box, it'll probably just be the same name as the publisher, as you might imagine. But this is where all that data is. And compression level, it can be set to nothing, to 0, or you can go from 1 to 6 for granular increasing levels of compression. If you're on GPRS, you might want to turn the compression to 6. If you're, HSDPA, you might be fine with just a little or no compression, just depending. The buffer size, this is a setting you can set on SQL CE that allows more work to happen. It makes a big cache of memory, a buffer in memory, where more work gets done in memory before it flushes it to disk. This is critical if you have a large database to sync with hundreds, 300, 400 tables maybe. In rare situations where you'd have something that big, making this value much larger. If you have the RAM available, you should. And you'll be able to not only sync more tables, but you'll get more work done faster. Different connect timeouts, receive timeouts, these are all values. And in my book, I talk about when to use different values based on different, it's also on MSDN, on different types of data networks. There's different values and timeouts to choose. So that's all good. And then, the kind of code here, I want to actually show you some diagrams. I know we only have about 5 minutes left. But this is kind of what the code looks like. Right here, I'm using a cache, a singleton to do everything. But basically, all those configuration files you saw there, so you're not just hard coding it. It's just reading all those things in for publisher, subscriber, that kind of thing to do its thing. Some of the stuff it does that's a little different is you test to see if the database exists or not. And if it doesn't, you're gonna do this new add subscription, and it'll create the database and the schema, the referential integrity for you, and pull it down. But you may have seen examples on the web where that's all it does. And that's not enough to know that you have a database there and you can sync. Because some people say, oh, well, if the database is there, it's fine. Well, as it turns out, you may have had a failure or something before, and a shell of a database is there, but it's almost empty. It's only 20K or 30K. So what I do next is, again, defensive code is good code. So I also do a check of the file size, and just for fun, make sure it's more than 30K in size before I have a better confidence level that it's not just an empty shell of a database. But the key thing here, I put TIG counts and everything for there just to show performance. But the key thing there is all you're doing is setting properties and calling synchronize. So pretty simple stuff. I've got some certain error, native error numbers that tell me that if I synced and it turns out the subscription had expired, it'll automatically go, oh, that's what that means. And so without any user intervention, it'll immediately call the reinitialize subscription to true, upload its data, and then start again and synchronize and start the process over again. So it's kind of really on autopilot for you to keep going. So now, before we got about 3 minutes, I want to show you some pictures. This would be kind of your standard kind of scenario here. SQL Server Publisher at the top, your SAN, all the different types of data on different drives. I get we can't all do that. I know in smaller situations it might all be on one box, but this is just unoptimal. The ETL, those adapters going to another enterprise system, you've got domain controllers for all the users and groups and security. Then below that, all the IIS servers, and they're using network load balancing, or you can use some other load balancer from F5 or things like that. Then down here in your DMZ, you'll have either a reverse proxy that people will go through to publish out those load balance. So you'll have a virtual IP for the load balanced IIS servers. That reverse proxy will publish that out. Or you could be using a VPN instead, and that works fine. And then below that, you just see all the possible, we can, different versions of Pocket PC, Windows Mobile, it could be laptops, whatever. It could be using ActiveSync. They'll go through that. So that's kind of a standard configuration. Then a configuration that lets you scale out some more is where I'll put in a couple of republishers here. And it's basically saying, I'm going to have so many users here that I'm going to overwhelm a single publisher. So I'm going to break that out into 2 or more. And so you see the 2 republishers underneath it, and they've got all their own same stuff. And so what those do is they subscribe with no filters. So they both have the exact same copy of the data as the main publisher. And then we break out the users to hit one or the other, or that kind of thing, so that we never overwhelm it. You could also, again, do it where you do filter that data, and so maybe one republisher is for Deutschland and the other republisher is for Denmark, something like that. And that's how you carve out that data, and we're always reducing going down. And then everything else looks the same. And then this is a system I built in May for an insurance company, which can scale out every way you can imagine forever. And it's going over, OC12 private circuit between 2 data centers in different geographic locations for high availability and failover. And so I had the main kind of publisher over here, and then over on the right side in a different data center over in OC12, you had a republisher. So he subscribed to that publication, and then he republished to other republisher, a single republisher under him, and there's a republisher here, and then load balanced IIS beneath them in the separate data centers, and then different groups of people going to hitting different data centers. And the great thing about this, I was working with this great CIO who, he's a mainframe guy, and he loves to just forcibly take down his data center a couple times a year, and have the DNS start to move everybody over and to see how things work, because a lot of people don't ever test out their high availability, and they just hope it's all going to work out. And so he wouldn't let me build a solution that didn't look like this. And so it's great to build stuff like this and to see it work so well, and to just force everybody over and see that it keeps working, and everybody starts syncing on the right side when this side goes down. And because the great thing is all these publishers and republishers, they all stay in sync with each other. And so what you start to see is, wow, I went from a hub and spoke solution to something that started to look a lot more like the internet. Because even though you're a publisher or a subscriber, it's kind of just a name distinction. Any one of them can take over. and become in charge, because they all have the same data. So they're all changing, and you all see the same data going across all 4 of these servers, and knowing that I can take any of them out of the service and some other guy can take control. So it's great stuff. It gives you that great feeling of confidence that I built this bulletproof solution. It looks like the internet. It's designed to fail and keep on going, which is key. And so, planning for failure from top to bottom and seeing how I could multiple data centers within the data center, scale out with more Republish Er, scale out even with more IS servers. And so this customer was starting with 65,000 Windows mobile devices ready to go up to, I think, 180,000. And this is the path to get there. It might seem like you're climbing this impossible mountain, but once you see that there's this kind of path that you can get to where you just keep adding boxes, then you realize, yeah, I can do this. So it's great stuff. So anyway, I know this is a real quick kind of overview. Again, if you're interested in this stuff, please contact me. I'd love to help you. My book is really inexpensive. You can get it on Amazon for under 20 bucks. And it walks you through step by step on how to build all this stuff. It has all the performance tuning in there. And it's just a great low-risk way to mobilize an enterprise, which I think we all know that's the biggest thing that's happening. The biggest macro trend in the world today in high technology is people mobilizing mobile devices, wanting to do everything at the point of contact with customers instead of being tethered to their desktop. And so it's been a real fun ride for me, learning all this stuff, and hopefully it'll be helpful to you. Does anybody have any questions? I know we're kind of out of time. I got lots of cards I can give you if you want to email or anything like that. Anybody have any quick questions? Okay. Well.